Hi everyone, welcome to Triggered Precision Machine. We have another good show today. We're about to talk about something that I hope helps some of you out there who are watching. We're going to talk about how to properly mount and level a rifle scope. This is an absolute critical part of making accurate long distance shots, but it's also important for our hunting rifles and anything else you might mount a magnified optic to. So we're going to go over my process for doing this. I'm going to talk about why I do it this way. Then I have a couple tools in the toolbox that they're meant to expedite this process and make it a little easier. So we'll talk about the pros and cons to using those tools, and then we'll take a look at what the effects are of having a canted reticle when you make long distance shots. So we got a lot to talk about, so here we go. All right, so we have our rifle, we have our scope, and we have our rings and all of our tools. So the first thing I do with any scope, whether it's used or brand new, is I wipe it off with a little rubbing alcohol. So a little rubbing alcohol on a rag, and then I wipe down the scope tube where the rings contact. And we're just making sure there's no oil or dirt on the scope tube that we don't want to get between the scope and the rings. So, and likewise, I'll wipe off the rings as well, both top and the bottom halves. All right, and the rubbing alcohol dries really quick, and we're nice and clean and ready to go. All right, we're all cleaned up and ready to move forward. So now the first thing we have to do is we have to figure out where we're going to mount the scope in the rings and on the rail. And that's all determined by the eye relief of your particular scope. Some scopes have very forgiving eye relief, others not so much. It's very critical where we need to mount the scope in order to get that good sight picture. So I have these rings on here. They're just finger tight for now. We're going to take them off or move them later, so they are fine as is. And all we're trying to do at this point is figure out where the scope needs to be so we get a good sight picture. And what we want to look for when we get behind the rifle is no shading around the edges of the scope and clear edge-to-edge sight picture. So the way we do this is when we get behind the rifle, I'll do it in a second, we want to close our eyes and settle into a good, comfortable, natural shooting position. At that point, we're going to open our eyes up and we're going to take a quick peek through the scope. And trust what your eyes see at that first moment that they open. That's going to be what you need to adjust or keep. So if we keep our eyes open for long enough, people have a tendency to compensate for what they see by moving their neck forward or backwards. We don't want to do that. We want to have the scope set to where our face is when it's in a natural, comfortable position and you're not stressing your neck or getting in an unnatural position. So I'll do it. So get behind the rifle, build up a nice shooting position like you normally would. Close your eyes. Then you open your eyes, and you can repeat that. All right, make a slight adjustment here. Settle back into the rifle, open your eyes. And that's perfect. So I kind of cheated because I've had this scope on this rifle before, and I know roughly where it needs to go, but if it's a new scope or a new rifle for you, you might have to play with it a little bit, and you can have a buddy help you out and kind of slide it back and forth until you have that perfect picture. So that's pretty easy. Now the next part is we have to take this scope in and out of these rings a few times throughout this process, so we don't want to lose what we just measured. So there's two ways that I will do it. I'll take a Sharpie and put a little tick mark here on the side that I can line up with the rings if the rings are in the right position. Or I'll take a piece of painter's tape and put it over the scope here to mark the location with the rings. While we're figuring out our eye relief, we also need to pay attention to where our scope rings are on our scope tube. So I like to have my scope rings spaced as far apart as possible. I'm not sure it matters either way, that's just how I like to do it. But once we have our scope rings where we want them, our scope is marked so we can put it back in the same place and have that same eye relief we just checked for. Pop our scope off, and now we need to torque the scope rings down. So on this Picatinny rail, most rings that fit on these rails have some slop in them. There's a little key on the bottom of your rings, and it allows the ring to move back and forth in the Picatinny rail slot, maybe 20 or 30 thousandths of an inch. So what we want to do is push the ring to the foremost position all the way forward in the slot, and then I hand tighten them down. And same thing with the rear ring, and we'll hand tighten those down. And then we want to refer to our manufacturer's specs for our torque value. These are set at 65 inch-pounds. This is a preset 65 inch-pound torque wrench. And make sure that we're using inch-pounds instead of foot-pounds. I've seen people try to put 65 foot-pounds of torque on their cross bolts, and the results weren't good. So we'll torque these down to 65 inch-pounds. Make sure they're all forward, and they're torqued on. All right, just a quick recap. We have our bottom ring halves torqued on to our Picatinny rail. They're cleaned, and we have our scope tube cleaned as well. So we're ready to really get started with mounting and leveling this scope. So downrange out the shop door, about 35 yards away, I have a camera tripod set up with a piece of construction string hanging in the middle. At the very bottom of that is a plumb bob. So that gives me a perfect vertical reference to align the scope to, and that's what we're going to use. So real quick, let's take a walk down there and I'll show you what we got. All right, guys, we're walking out here to the parking lot. Nice day, but it is about 16 degrees out right now, so we're going to stay in the shop as much as we can. So we're about 35 yards out now from the position you just saw me in, and all I have here is a camera tripod with a piece of contractor string or construction string, some really bright neon orange string, and there's a plumb bob at the bottom. So we know that this string is hanging perfectly vertical, and that's what we're going to use to align our scope reticle. So let's head back into the shop and we'll keep going. All right, we're back inside the nice warm shop. So now we need to get our rifle lined up with that string downrange. And I have it pretty close right now, but what we're going to do to make it even closer is put our scope in the rings, and we're going to get behind the rifle and line it up best we can. And we're not worried about the rifle being level right now because we're going to jump back up and do that with a machinist level in a second, but we want it to be pretty close. So this is a good time to double check your eye relief as well. And just a slight adjustment to the left, and I have my vertical crosshair just off to the left of my string, about 1/2 inch, and that's where I like to have it. That way we can reference the gap between the reticle and the string the whole length that it's in our scope. All right, so now we have everything lined up. So from this point forward, we need to be careful and not bump the rifle and throw our alignment off of this string. So we're going to pop the scope off carefully. We'll set that down here. And now we're going to level off the rifle. So I have a Harris SBRM bipod in the front, and that's a swivel bipod or a cantable bipod. So it lets me cant the rifle to the left and right. So I have the pod lock adjusted, so there's medium tension on it. So when I cant the rifle in order to level it and I let off of it, it'll stay in that position. And in the back here, it's just a sandbag, and I have the rifle roughly leveled with the ground. So we're going to take our machinist level here, and we're going to use the Picatinny rail. You can use any nice flat surface you have, and we're going to level the rifle with that. A lot of rifles don't have these Picatinny rails. If you have part of your scope base that's flat enough to use for a level, you can use that. I've used the top of these, the bottom half of the scope rings before, and you can just set your level on there like that. That works as well. But we have a nice flat Picatinny rail here, so we're going to use it. So once we get our level on there, it's just very small adjustments back and forth. And that's right about where we want it. So that's perfect. Oh, came back a little bit. And it might take a little playing around with to get it just right, but get it as accurate as you can. So now we have our rifle leveled, so it's holding steady right now. Now we got to carefully take off our level, and we're going to put our scope on. And remember, we have those marks on our scope where we can align it with our rings. So we're going to carefully put our scope back on. Right there. Okay. Now we're ready for the next step. All right, now for the fun part. Now we get to align the scope to our string downrange. So what we want to do is we're going to get behind the rifle, and all we're going to do is simply rotate the scope so our vertical line in our reticle lines up with the string we have down hanging off the camera tripod. So like I said, originally we lined it up about a 1/2 inch off to the left of the string, and I like to just check that gap and make sure that gap is even from the top to the bottom of the string in the reticle. So if it happens to move a little bit when we were doing our adjustment, it's fine. Just make sure it's close enough for you to get an accurate reference and measure that reticle and the string. So we'll get behind it and we'll see what we got. All right, so when you're down behind the rifle, make sure you don't touch your cheek to it. Make sure you don't touch anything except just very lightly rotating the scope. And all we're going to do is just rotate it a small amount until our vertical reticle line is perfectly lined up with our string line down range. And right about there. That is perfect. All right. All right, so we have everything lined up perfectly. The rifle's leveled, the scope is leveled, and both of those are leveled to our vertical line down range made by our plumb bob and the Earth's gravity. So let's lock it down. Now we got to put our ring caps on and make sure that if there is a proper orientation for your ring caps, you follow that. And just very carefully, we'll get these screws started with my Torx driver here without bumping anything. Just very careful. All right. We'll take our rear cap and we'll get this ready to go. Set that on there and start these guys. And very carefully get the Torx screws started. All right. All right, before we go off and torque down all these screws, we got to make sure that our ring caps are in the right place. And what I mean by that is there's generally a gap on either side of the ring between the top and the bottom portion. So we want to make sure that that's even. On these TPS rings, there should be about a 20 thousandths gap on either side. So as we're tightening these down slowly, we want to be mindful and make sure that that gap is as even as we can get it on either side. So different rings have different install procedures, so you're going to want to refer to the install instructions that came with your particular scope rings. So we'll get all these where they need to go. And just make sure that that gap is even on the other side, and sometimes it's just a little bit of give and take and you'll level it out. That looks pretty good. And then we'll just go finger tight. Very light. All right, our cap screws are on there finger tight. Our gap is even on either side where the top cap connects to the bottom base, and we're ready to start torquing these things on. Now once again, we got to refer back to our scope ring manufacturers to get the torque specs for our rings, but also very important, just because our scope rings say they want 25 inch-pounds or 30 inch-pounds or something like that, you want to double check and make sure that your rifle scope can take that kind of torque. So not every rifle scope is built the same. Some of the lighter target scopes and lighter hunting scopes don't like that 25 and 30 inch-pounds of torque on them. So they might require 18 to 20 inch-pounds or something like that. So I tend to use the scope manufacturer's advice for how much torque they want on the scope rings. So this one's good with 20 inch-pounds, so we're going to go with that. So I have my little Wheeler fat wrench right here, and we'll set it for 20 inch-pounds. And once again, make sure that we use inch-pounds and not foot-pounds. Seen this done before where someone also tried to use 20 foot-pounds. So what we're going to do first is we're just going to go about a quarter turn, and we're going to use a cross pattern. So we're going to go from the upper left down to the lower right, and then back over to the lower left in about a quarter turn, and then the upper right for about a quarter turn. And all we're doing is evenly distributing the torque on the entire ring cap and the scope tube. So we're not getting a spot where there's more torque and it's going to dent your scope tube or something like that. So now I'll do the rear ring and just about a quarter turn. That same diagonal pattern, so upper left to lower right, back over to lower left, and then back up to upper right. All right, so those all have a little bit of torque on them now. So now we're going to go through and actually torque them to spec. So I'll start up at the upper left, 20 inch-pounds, and lower right, and lower left, and upper right. And same thing with the rear. Then I go over them one more time just to make sure that everything's even. Same pattern. All right. And that's it. So our scope is now properly leveled and torqued on, and this rifle is ready to shoot. We'll take a look at some of the other tools and methods to mounting scopes, and we'll talk about some of the pros and cons, and then we'll step back into the office, and I have JBM ballistics pulled up with a couple different ballistic charts, and we're going to demonstrate just what effect a canted reticle will have on your rifle for long distance shooting. So let's take a look at these tools first. All right guys, I went ahead and grabbed my scope leveling tool. This one's made by Spur. They make very high quality mounts. So here's the tool. It's made out of aluminum. Very, very simple design. It's got this lug on the bottom. You line this up with the center of your scope turret housing and slide it on your Picatinny rail beneath your scope. And then you have this little wedge tool here. This just goes in that little spot, and you can slide it up and down for different heights, and you want to go until it contacts the bottom flat of the scope turret housing. And then what you do is you kind of rock your scope back and forth very carefully until it's perfectly level with this tool. So the problem with these tools are a lot of times, especially with cheaper scopes, and when I say cheap scope, I'm talking stuff that's probably less than $1,500. So in reality, they're not cheap scopes. But we can't guarantee that our scope reticle is lined up to the bottom flat of the scope. So the manufacturers don't guarantee that method for leveling your scope. It is one way out there that a lot of people do it. And I usually carry these in the field just in case I have to take a scope off and re-level it. It's a good kind of rudimentary method to do it, but it's not something that I would trust for extreme long-range shooting or any sort of precision long-range shooting. So I'd always double check with levels if I could. All right guys, we have our Spur scope level down here, and a little bit better view on how it actually works. So you slide this little piece until it locks into the little Picatinny rail and it sits flat. Then we take our wedge and you line it up with the slot and it goes in there like that. So it doesn't work on this rifle because the scope is too low and the wedge can't get in there far enough to give you a good level. But this is how it works, and most rifles have more space between the top of the Picatinny rail and the bottom of the scope turret housing. And one more way that I commonly see people trying to level their scopes is using our elevation turret cap. So similar to the bottom edge of this surface, there is no way to tell that this surface right here has any relation at all to where our reticle is positioned within the scope tube. So theoretically it should be in line, but I mean, these scope turrets will move a little bit. There is some play in them. And if we're trying to be precise, that's not the way to do it. It might get you close, you might get right on if you're lucky, but that is not the correct way to level our scope. And then a lot of people struggle with leveling the rifle. So they'll run a piece of sheet metal or something, or a bubble level off the rail down here, and then try to level their scope off the turret like this. And yeah, you can get close, but it's not going to be as good as what we just did using the Earth's gravity, a string, and a plumb bob to level our reticle. All right, guys, we got our scope nice and torqued on and leveled, so we're ready to go shoot this rifle. While the camera's down here, take a look at where the scope rings are set up on the scope tube. So I have about 1/4 of an inch up here in the front before the scope bells out to the objective, and same thing with the back. We have about maybe 3/8 of an inch here before we reach our magnification ring in our ocular. So that's how I like to do it. And once again, I've never seen any data that shows that this is any better or worse than anything else. It's just the theory of it in my head makes sense. We have kind of just a wider mounting point, a wider base for our scope, which I would think gives a little bit better longitudinal stability. So now we'll go ahead and we'll jump on the computer and we'll plug in some data that shows the effects of having a reticle canted and what that looks like downrange as far as our impacts. So let's jump on the computer. All right, we're back here in the warm office, and I have pulled up JBM Ballistics and made 3 different trajectory tables. I just used the input data for my 308 Winchester. It's an 18-inch gun, puts out about 2,600 feet per second velocity with a 168 grain Sierra Match King, and the environmental conditions roughly resemble what I have here today. But the important thing is that all of those variables are the same for each of these trajectory charts that we're going to look at. The only difference is the cant angle. When we're talking about cant angle, it's important to know that each manufacturer has a different tolerance level for cant angle in their finished product. The higher end scopes like Schmidt & Bender, Tangent Theta, and Night Force all have a very low tolerance for cant angle. Usually it's around 1/2 of a degree. On the other hand, the mid and the low range manufacturers often open this tolerance up anywhere from 1 degree to 5 degrees, which is huge. So if by chance we were to have one of these scopes with a severely canted reticle, and we mounted it and leveled it using one of the 2 methods that are very popular these days, either using the top of the scope turret or the bottom of the turret housing to level the scope, then when we shot that rifle, we would fully experience the effects of having a canted reticle. The way we mitigate that is by leveling the scope to the reticle. We use something that is known to be exactly horizontal or vertical, like I showed you, and we level our reticle to that object. So we used a plumb bob and a string, and we don't have to worry about our reticle being level after that. All right, we'll take a look at this first trajectory table, and this is the 0 degree cant angle, and you'll notice the windage column is all zeros. So our bullet is flying true to our reticle all the way out to 2,000 yards. And I've highlighted 2 different distances that we're going to compare for each of these charts, 500 yards and 1,000 yards. And now we have our second table up. This one has a 2.5 degree cant angle, and once again, all the input data is the same. So we go down to our 500 yard drop, and we notice that our windage now has 3.7 inches of deviation. We go down to 1,000 yards, and that's magnified out to 21.9 inches of deviation with just a 2.5 degree cant angle. And 2.5 degrees is very, very minimum, but it still has a pretty significant effect, especially when we get out to distance. All right, here's our third table. We have 5 degrees of cant angle built into this one once again, and we'll go to our 500 yard line. We see we have almost double the windage deviation at 7.5 inches. Then we go down to 1,000 yards, and we have 43.7 inches of windage deviation at 1,000 yards with a 5 degree cant angle. That's getting very significant. And a 5 degree cant angle is very possible for someone to have and not notice. So when we think about all the things we have to take into consideration when we're making a long shot, and that's the level of the rifle, the level of the scope, the wind, and our trajectory of our bullet, having a leveled scope simply eliminates one of those variables that can compound into a miss at long distance. So it's one of those things that we can easily control. There is no magic behind it. All we're doing is leveling our scope to the earth using something that we know is perfectly vertical or horizontal. So very important to do. I would highly recommend using a scope mounted level. And if I were using a scope mounted level on that little 22, I would have installed it at the time that I leveled my scope. That way we know everything is in line and there is no deviation between the level of our scope and our level. So there's a lot of good options for levels out there. Some of them actually will attach to your Picatinny rail, some of them attach to your scope tube, and it's kind of personal preference at that point. But those are great things to have if we're going to shoot past 500 yards, because as you can see, the deviation can be very significant. All right, that's it for today, guys. This is a really interesting topic, and I hope that these three charts show the dramatic effect that having a canted scope or rifle can have when you take a long range shot. So I just showed you a very foolproof and simple way to level your scope. You don't need any special tools. So if we do that, we can eliminate this one factor, and then we can focus on the wind or our ballistics when we try to make a long range hit. So get out there and keep shooting and practicing, guys. And thanks for watching, and I'll see you next time.